Hi, we start this video with the section 1.1. And the name for this section is Introduction to Matrices and Systems of Linear Equations. All right, first, a linear equation is one that can be written in the form usually you see a linear equation. I think the most common form that you have for a linear equation is this: y equal to mx plus b. And maybe you remember that this graphically is a straight line. But here we would use a different notation. Instead of the y, I will be using only x, but with subscripts. For example, x2 playing the role of the y, so will be x2 equal to m times x1 plus b. No, it's the same thing, but instead of the y, we're using only x and with subscripts to identify or to distinguish the different x numbers. This equation, in general, can be written in the form ax1 plus bx2 equal to c. And this, if you see, is, well, we will call this linear equation in two variables. So any linear equation, it's coming from graphically from a straight line. We will be using the notation x2 equal to mx1 plus b, and if we have more variables, we're going to be using x. Again, the difference is going to be the subscript, and in general, it can be written in this form. So, but in this form, we have a linear equation in two variables. I think, of course, it's equivalent to this one. For example, if I have y equal to 2x plus 3, notice that this can be written as y minus 2x equal to 3. Or what is the same is negative 2x plus y equal to 3. So I have this form, y equal to mx plus b, or x2 equal, well, in this case we are not using x2, but, and in this case is, let me write it with only x, negative 2x1 plus x2 equal to 3. So this form, notice how it has the form x1 plus b x2 equal to 3. So the point of this is that any linear equation in the form y equal to mx plus b can be written in the form ax1 plus bx2 equal to c. So linear equation in two variables is essentially graphically a straight line. Yeah. Now, solution. A solution for a linear equation is an ordered pair in the form x1 comma x2. Here, of course, I mean, not any pair is going to be a solution, but here the order is going to be important because the first element corresponds to the x1 and the second one corresponds to the x2, or whatever you want to label the variables. If this were x and y, if this were x and this y, then the first value corresponds to the x and the second one to the y. So that's why this order is very important. So an ordered pair of numbers is a solution if when we substitute into the equation we obtain a true statement. Or maybe we can say a true equation, but that is kind of weird to say that a true equation. Can we have a false equation? I think if we have an equation, it's supposed to be true. But well, that's why I say true statement. For example, given the equation 5x plus 1 plus 2x2 equal to 3, we can verify 1 comma negative 1 is a solution. Because when we substitute this pair, and notice this is again, this is important, this is for x1 and this one is for x2. So if I replace this into this equation, into this one, then I'm going to have 5 times 1 plus 2 times negative 1 equal to 3, and this is the left side of the equation, should be equal to the right side. So this is the left side, and notice it's equal to the right side. So 3 obviously is equal to 3, so we have what? A true statement. So this is a solution. How do we know a given pair is not a solution? If we try any pair, we substitute and we don't have a true statement. Just like that. So with this, I will be giving to you many questions to think about them, right? Not necessarily that I will respond or I will give you the answer to the questions here in the same video. Maybe I will do it for another video, or maybe I will create a discussion board about this question, but I will be giving to you questions, all right? To think about them. Again, maybe I will respond to them later in another video, or maybe I will create a discussion board about that. But first question for this is, think about this. How many solutions are there for one single linear equation in two variables? How many solutions for one single question? I mean, for one single linear equation in two variables, I mean. Yeah? Think about this. So once we have understood what a linear equation in two variables is, now we have a system of two linear equations in two variables. Is a system in the form a11x1 plus a12x2 equal to C1, and a21x1 plus a22x2 equal to C2. Here the subscripts are going to be important to denote or to understand what coefficient we're talking about. The coefficient is the number multiplying the unknowns or the variables, and by the unknowns or the variables I mean the x, for example x1 and x2. I will refer to them as unknowns or variables. But notice, this is a number, a real number. A11 is not of course A11. You have to read this as A11, and it means what? The coefficient in the equation 1 and in the column 1. Equation 1, column 2. Equation 2, column 1, equation 2, column 2, right? So that's why we use those subscripts to identify the coefficients. This is going to be important later when we use matrices. So, for example, one example of one system of two linear equations is 2x1 plus 4x2 equal to 5. 5x1 plus 6x2 equal to 7. Part B, x1 minus x2 equal to 2, and x1 plus x2 equal to 3. And we could label this with equation 1, equation 2, equation 1, equation 2. See? And of course, as any solution, well, let me write it here. A solution for a system of two linear equations is a pair in the form x1 and x2, but it's the same as before. One solution for a system of two linear equations is going to be one that once we have substituted into the equation, we obtain a true statement. But in this case, we need to obtain a true statement for all the equations. But it must satisfy all the equations, in this case too. For example, for this one, I think you can verify easily. For this system, a solution is 2, 1. Substitute here, 2 minus 1. Oh, it is not right, I'm sorry. Well, I'm sorry, I can change this number to 1. And then we will have a solution, right? 2, x1 minus x2, 2 minus 1 is 1, true statement. 2 plus 1 is 3, true statement. So this is a solution for the system. You see that? It must satisfy all the equations. If you find one solution for one equation, but it doesn't satisfy the other equation, then it is not a solution. Again, this is very important. If you say you have a solution for a system of equations, then it must satisfy all the equations. All the equations, okay? By the way, geometrically, for a system of two linear equations, we have only these possibilities. The first, notice, geometrically, this is not very complicated to do once we have understood that every linear equation represents a straight line. And since we have two straight lines, we have two equations, then we have two straight lines. If we have two straight lines, the only possibilities as for the solution for a system of two linear equations are the next ones. Number one, we have only one solution. Number two, no solution. When does this happen? When the lines are parallel. And finally, infinitely many solutions. Why? Because the two equations are equivalent. Or we can say that we have a system with the same equation. If we have one system with the same equation, then we have only one line. infinitely many solutions. So we can have only these cases. That okay? For a system of two linear equations. By the way, some of the exercises on the first homework for this section is that you have to verify graphically the solutions. You already know that these are the only possibilities, right? So far, so far we haven't seen any method to solve this system, algebraically by computations, but we can do it graphically. So what we can do is you can sketch. I strongly recommend when you're going to graph in 2 dimensions, like is the case for this particular exercise, I recommend to use this web page. It's desmos.com. It's a graphic calculator. I know I'm sorry, I have to send it here in Spanish, but I think in English will be easy to understand. You have to click here on the part where it says graphing calculator. It says in Spanish calculadora gráfica, but in English would be graphing calculator. Just you click there and notice it's simple, right? So don't worry if you see this in Spanish. When you see it in English, it's going to be perfectly to understand. So and what you have to do literally is only type the equations. For example, if I type the equation before, the system before that I had before, x plus x minus y equal to 2, no, equal to 1, right? And the other equation, x plus y equal to 3. And notice what is happening here. I have the two equations, the three straight lines in this case, and the intersection point is the solution. You see 2, 1. So if you have to verify graphically that a system of two linear equations in two variables has solutions or not, you can do it here with this web page, Desmos. It's highly recommended. All right, now going back to the notes, but of course, we are not going to focus only on systems of two linear equations, right? The purpose of this course is stronger. So in general, we can have m times n, m equations, and n unknowns or variables. System. One in the form a11x1 plus a12x2 and so on until the a1nxn. The next row, a21x1 plus a22x2 plus a2nxn, and so on. And so on up to the row, up to the m equation, m1, I'm sorry. We are in the equation m in the variable 1, so x1 plus am2x2, and so on until annxn. And of course equal to some numbers, c1. Well, I think it's better to use b. b1, b2, and so on, bm. So this is supposed to be a system of m equations with m variables. We're going to, of course, the purpose of this course is that we study with certain depth how to solve this kind of systems. Or well, even if we don't for sure here in this course. Even when we don't have all the practice to solve this, to solve any of this manually, for sure you're going to learn how to solve or how to know the solutions, how many solutions are right, or when it doesn't have solutions for a system like this. It's one of the purposes for this course, all right? It's for sure. We will see that later. So, but by now, one question for you. You know, for example, in this case, for the case when we have a system with only two equations and two variables, this happens. So what do you think can happen in general for this? How many solutions? What are the cases? I mean, for example, when we have two two equations and two variables and two unknowns or variables, we know these are all the possibilities: one solution, no solution, or infinitely many solutions. What do you think is going to be the case for a system like this? Yeah, think about it, or I recommend to read the book or look for that in the internet. Again, for sure, I will have to mention this in other videos. But again, by now, if you want to think about this or to know the answer for this, I recommend you to look for it. All right. Finally, a mathematical object that we're going to be using here a lot, and actually this is the name of the course, right? Matrix theory. We're going to study this a lot in this course. So by now, a matrix is only a rectangular array of numbers. Enclosed between big brackets or parentheses. So for example, array of numbers, and by numbers I mean real numbers. 1, 2, 3, 4. Other example, 5, 7, 8, 9. Other example, -1, 0, 2, 1/2, 4, 5, 3, 1, and -2. You see, these are arrays. I can use parentheses too. For example, 1, 2, 3, 4. Supposed to be 3, 4, not 34. 3, 4, separately. All right. So something important about these arrays is that we can be able to identify the size or the dimension. The size depends on the number of rows and the number of columns of the array. For example, here we have 1, 2 rows and 1, 2 columns. So you write this is a system with size, or I mean a matrix with size 2 by 2. This one you can verify is 4 by 1, and this one you can verify is 3 by 3. And this one is what? Yeah, 4 by 1. See that? You have to mention first the rows and then the columns, and with that you will have the size for the matrix. Augmented matrix. Any system of linear equations can be expressed as a matrix that is called the augmented matrix. Augmented matrix. For example, given the system 2x1 minus 3x2 equal to 5, and 4x1 plus 2x2 equal to 6. This is the equation 1. This is the equation 2. This can be expressed as a matrix. Notice how this is not very complicated to do, so pay attention. You will have to create a matrix based on the coefficients for the equations. The first equation is going to correspond to the first row, to the first row in this case. So the coefficients, by coefficients I mean the numbers multiplying the unknowns or the variables. So in this case we have 2, -3, and 5. 2, -3, and 5, see? And for the second row, for the second equation, we have a second row. Again, 4, 2, 6. So you see, we can think for any given system of equations, linear equations, we can have a matrix. This is called the augmented matrix. By the way, if we want to, it's optional that we can use here this vertical line to denote that we're talking about here the left side of the equation, and this is the right side of the equation. You see that? Maybe in the assignments on Whiteboard you won't see this line, but here in the notes I will be using this, and maybe in the book you will find it. You will find it as well. So this is in the form. We have a matrix in the form A, B, where A is 2, -3, 4, 2. This is the left side, and the matrix B is 5, 6. You see that? So with this, we say that we can express any systems of linear equations, no matter the number of unknowns or equations. We can express it like this, in this form. You see that? By the way, to finish with this, the matrix A, as before, is called the coefficient matrix. This one. Is that okay? Of course. Later we will see how to solve some techniques too. It's important to see that some methods to solve the equations by using the augmented matrix. We will see more properties, but we will see that later. For this video, that is all. Please try the corresponding assignment for this video. Maybe I can post a discussion board. Maybe after I have posted the video, right? So please, by the way, very important, if you are watching this video or listening to this video until this point, please be aware of the announcements on Blackboard. Those are very important so that I can communicate with you. All right. See you later.